Welcome back to Ignited Minds. So as I've started with English literature videos, mathematics videos, craft videos and etc. Since I am an engineer, so I thought of revisiting those memories of my BTech where I had learned about computers. So today I'm going to share about a topic which is very important these days. Even if you have not studied it, somewhere or the other you must have heard of it. So the topic that we are going to study today is network security. Now security, if I say, means to safeguard something. Suppose if I say you have to safeguard your homes. How do you secure your homes? Through locks, right? You get a key. If I ask you how do you secure a cupboard, how do you lock a cupboard? So you use it through a lock which nobody can open. So in terms of computer, security is the same, but in terms of lock, we use security in terms of encryption. So let us start from the basic. Why do we actually need this security in the network? What makes network a prone thing that we require certain encryption and decryption techniques? So let's start. So as you all know that the computer networks are a shared resource. On a same network, you can have multiple applications accessing the same network. Now the drawback of this is, if many people are using the same network, there are higher chances of data being leaked or data being accessed or used. So how do you save it? Suppose I'll give you an example. You are purchasing something and you use your credit card credentials on the system, on www, World Wide Web. So it becomes a problem for you. How do you know that your credentials are saved? Suppose there are 10 users who are using Amazon and they are using their credentials. Who can say that 10 users' credentials are saved? So for that particular reason comes the concept of network security. Now the basic things, what is happening right now is, whatever the information is sent or it is being delivered, it is a plain text. Suppose there are two people, one is user and the other is receiver. So the user will send the data or the text and receiver will receive it. So the user has to send the data in such a form that there is no security issues. So how it is done? The user encrypts the data. Now what is encryption? When you simply change the plain text into a cipher text. What is cipher text? I'll explain you here. So encryption is simply converting the plain text into a cipher text, into a coded word. A simple word is transformed into a coded word. That coded word is passed on through the network and then the receiver decrypts it or decodes it. It again gets it back to the plain text. So the cipher text is again changed into the plain text. Suppose, for example, I have to send my number, my credit card number, credentials I have used, which is 12112. So now it will be coded into a cipher text and it will be AXB11 as an example. So this will go to here and then again AXB11 will be transformed into 12112. Now this cipher text is supposed to be secure. There is a key that is shared and this doesn't allow the other people or the hackers to hack your data. Now how is this done? Can you randomly write anything? Can you do the decoding or coding yourself? No. There are some techniques that are being used. So let us study those techniques. So the first technique is substitution technique. Now from the word itself, it says substitution. To put another word in place of that word. As I did here, in place of 1, I put A. In place of 2, I put X. So when we substitute individual alphabets one by one, it is called substitution techniques. Now there are some subdivisions of this substitution. Now substitution can be done in various forms. The first one is Caesar technique. Caesar technique is that there is a same pattern followed in substitution. Like if you talk about A is substituted by D. That means after A, two alphabets are removed, B and C. Again, B is replaced by E. Now after B, again two alphabets are removed, C and D. That means A and B are following the same pattern of missing 2 digits. So this is what is called Cipher technique. That means a similar technique of replacement is used. But it is little risky. If the technique is known to the person, then he can easily hack, because it's the same technique in all the alphabets, right? So this is not a very good substitution technique. Now talking about monoalphabetic. Monoalphabetic technique has no particular relation. A can be replaced by Z, B can be replaced by Y, and so on. So there is no particular substitution or the particular relation. Next is homophonic. Homophonic means a single character can be substituted by many characters. Here what we were doing was one character was substituted by one character only, right? No matter what is the relation, but one was substituted by one. In this homo, from one character can be substituted to more than one characters. Like A can be substituted by B and Z both, or B can be substituted by any number of character. Now it is polygram. Polygram means when a block of words is being substituted. Here we were talking about alphabets. Polygram means when a group of words or a block of words is substituted by block of characters. As in, if we see hello, hello is a word, HELLO. It is a complete block which was substituted by YUQW. Now these were the substitution technique where you have to change the alphabets, where you have to change the characters. Now the another encryption technique is transposition technique. In transposition, the characters are not changed, but the characters are rearranged. Here what we have done, we have completely changed the characters. But in transposition, we do not change the characters, we just rearrange it. Now again, there are many kinds of transposition technique. The first one is rail fence. Now in rail fence, the concept is pretty easy. Suppose we have a plain text here, come home, COMEHOME. So according to transposition, you have to place these alphabet row wise. As in, the cipher text will be CO, first row, ME, HO and ME. So when the plain text is put row by row, it converts into the cipher key. This is the encrypted cipher key for this plain text. Next is simple columnar transposition technique. It is also very easy. Now for an example, if we have a word 5 minutes engineering. Now this is a plain word and we have to get a cipher key of it, or we have to make it in encrypted format. So what we'll do it, we'll just take a block. The block can be of any number. It doesn't mean that you have to make 5 into 5. You can make it 4 into 4. You can make it 6 into 6. It doesn't matter. Now I have taken here 5 into 5 column and rows. Now what we'll do is, we'll simply put this alphabet row wise into this column and row. FIVE 5, MINUTE minutes, SENGI NEERING engineering. Now if you can see, the last 3 blocks are still not occupied. So leave these 3 blocks. Now the next thing is, and you have to make sure that the substitution is done from L to R, left to right. You cannot just start from here, FIVE, no. You will start from left to the right. And you will number them as 1, 2, 3, 4, 5. Now you have to make a key, a random key on your own. Now the one property that has to be kept in mind while making a key is that it should not exceed the number of columns or the number of rows. Now here 1, 2, 3, 4, 5. So the key has to be less than 5. Any arrangement of numbers which are less than 5. You cannot make it 4, 6, 1, 2, 3 or 5. It will be wrong because here it is 6 and we have only numbers till 5. So the key can be any random arrangement of numbers. It can be 4, 3, 5 and 2. It can be 4, 1, 5, 2, 1, anything. So now if we follow this 4, 3, 5 and 2 is our key. Our text is 5 minutes engineering. Now how can we decode it? What you will do, simply see this 4 column. 4 column is here, ETGR, right? ETGR. Then it is 3, VUNE, VUNE. Then it is 5, MEII, MEII, and so on. So this is the cipher key, cipher text for this plain text. What we have done, simply make any column and rows, any group of columns, put them or substitute the alphabet row wise, then forget about these items, then make a random key. The key should not exceed the number of columns, and according to the key, whichever number is there, put all the columns line wise. Now the last is Verman cipher. Verman cipher is also similar. Suppose we have a plain text hello here. Now in this, what we do here, we had made a column and row. Here we see what are the alphabetical digits, what are the position of these alphabets. Now if you see, the position of H is 7, position of E is 4, position of L is 11, position of L is again 11, and position of O is 14. Now we have a key with us which is DGHBC. The same process that we did with hello, we'll find out the position of these elements and write it below them. It is simple. We had a plain text hello, we checked their positions in the alphabet and we wrote it here. Then again we checked the position of the key, the cipher key that has been given to us, and then we wrote the positions behind them, under them. Now to convert from plain text into cipher, when we have to convert from plain to cipher, we add the digits. Now if you add 14 plus 2, 16, 11 plus 1, 12, 11 plus 7, 18, 4 plus 6, 10, 7 plus 3, 10. So now this is the cipher code. Now check the value of 10 in the English alphabet, it is K. Again check the alphabet of 10, it is K, S, M and Q. So the cipher code of plain text hello is KKSMQ. Now if you have to decrypt it, you want this to be back to, you want to know what is the plain text key of it. Suppose if a question comes that this is the cipher key and you have to find out the plain key. So the similar process you have to use, you have to write down the main values, the positions of these alphabet, K10, K10, S18, M12, Q16. Now you will write this key which was given to us, DGHBC, and then again write these values here. So when we had to convert from plain to cipher, we added. Now from cipher back to the plain, we will subtract. So 16 minus 2 is 14, 12 minus 1 is 11, 18 minus 7 is 11, 10 minus 6 is 4, and 10 minus 3 is again 7. So now you get 7, 4, 11, 11, 14. Again try to find out what are their positions, H, E, L, N, O. You get this back again. So this is how the data or the alphabets are being transmitted. They are not transmitted if you send hello or some important information on the network. It is being encrypted and in the form of cipher text, it is being shared on the internet or on the network. Now there are some kinds of security attacks that can take place, which I'm going to explain in the next video. If you have liked this video and understood this video, please go like and subscribe your YouTube channel. Thank you.